Let me start off with a warning. In this lesson there will be math. We have this random number 0.6698 something, and every time I refresh the page I get a different number. But this is a bit unuseful. For example, I want like the sides of a dice. I want either 1, 2, 3, 4, 5 or 6. That is my ultimate goal. But to understand how we get there, let's take some steps in other directions. So I'm going to talk a bit about ratios, a bit about scaling, and a bit about translating. And you already know these words from images and transforms, and now we're going to use them on numbers. I find that it helps me a lot to think about numbers as being part of a line. So say you have 0 here, and then you have 1. Then you would have a line in between those, starting at 0, ending at 1. And every number between those two would be somewhere on this line. So here around the middle you would have 0.5, and then 1/4 in, of course, you would have 0.25, and here close to the end you would have, say, 0.9, and all the other numbers would be in between there. And this is where our random numbers lie. But if we wanted them to be in a different scale, say we want them to be from 0 all the way to 100 on this longer line here, then say, okay, so the first would be fairly easy. 0 would be, that would go directly, that would be 0, of course, and 1 would be 100. And then say, okay, so what about 0.5? Well, that would be somewhere around the middle, somewhere around here. That would be 50. And if we go here with our 0.25, that would be right here at 25. And of course, if you just go all the way to the 0.9, that would go here, around here at 90. You could just draw the dotted line to it. So we see that this line is much shorter, but we just scale it up to the larger line simply by multiplying this number by 100. So because this goes to 1 and we scale it so it shouldn't go just to 1 but to 100, we multiply it by 100. It's fairly simple, right? So that's what we want to do here. And we can just modify the same number. Say now this number is equal to the same number multiplied by 100. And this gives me a number between 1 and 100. This is 28. And we have 17, 79, 40, 3, 99. It's almost 100, but not quite. And this is also important to remember, because if we take a look at the specification here, it says it returns a random number between 0 inclusive and 1 exclusive. So the random number will never become 1. And with our calculation here, it will never become 100. It can become 0, but it will never become 100. So much for simple scaling, just multiplying. That we can do. But what if we wanted it to be not from 0 to 100, but 1, 2, 3, 4, 5, or 6? So let's clean up this version of the scaling and just clean up these numbers here as well. We still have our random number between 0 and 1, but now I'm going to do it a bit backwards. We want the result to be from 0 to, from 1 to 6. 5, 4, 3, and 2 in between. And then we need to figure out what is the ratio. What should each one correspond to? So first of all, we can see that 1 that would be 6. No problem there. And then what about 0? Would that be 1? Oh, how do we calculate this? Let's draw a calculator in. We want to say, okay, we have the 1 divided by 6. That gives us 0.166. So that would be the first 166. And that would be our 1. And then the next, and now I need the calculator again. So I can just add, that would be 0.33. And if I add again, that would be around here. And now I'm drawing in green, 0.5. And I can see 0.66. And the last one, 0.83. So 0.5 would be 3. 0.33 would be 2, and 0. And so on. So here, the scaling is the same. We simply multiply by 6. Let's try that first. I know there's going to be a problem, but let's try it. Multiply by 6. We have 2, 2, 2, 4, 1, 1, 2, 3, 3, 2, 1, 5, 4, 0. Now we have 0. That's not a valid side. 0 is certainly not a valid side on the dice. It was so bad that even the cat felt the need to complain about it. But why do we get 0? Well, it all comes back to our calculation here. Because remember, 1 is actually it will never be 1. So it will never be 6. But we also, when we said here that 0.166 would become 1, what about everything below that? We have an area here that I'm drawing in red, where everything would be 0. And we don't want that. We want to avoid that. We want to say, okay, we want to shift up everything so it starts from 1. So a 0 here would go, and now I'm trying to, 0 would go to 1. And 0.16 would go to 2, and 0.30 would go to 3, and so on. But then, can you see the problem already? If 0 goes like this to 1, and 0.16 goes to 2, 0.33 goes to 3. I'm doing this slowly to make it obvious what is going to happen. Because 0.5 will now go to 4, and 0.6 will now go to 5, 0.8 will now go to 6. And what about anything that is 1 or almost 1? That went so bad it went outside. That goes to 7. 7 is also not a valid side on the dice. Okay. Anything here should be 1. Anything here should be 2. Anything here should be 3. Anything here should be 4. Anything here should be 5. And anything here should be 6. So we don't want to go all the way to 7. Say, certainly not. We want to round it, but if we don't go all the way, 6.9999, that could just become 6. And 5.99999, that could become 5. So if we round down, we multiply by 6, then we add 1, and then we round it down. So it can come down to 1, to 2, 3, 4, 5, or 6. Let us check that out. First, however, we need to know how to round the number down. So let's look at math once again. There's round here. That rounds to the nearest integer. Integer is a whole number, a number without any decimals. So round would say round a number to the nearest integer. 2.49 will be rounded down and 2.5 will be rounded up. Well, we don't want that. We want everything that is 1.999999 to be rounded down. So we actually don't want it to be rounded as much as we just want it to go that direction. If you just turn the line around here, it'll be a bit easier. If we say, okay, we have the number 1 here, and then we have the 0 here, and the line goes like this. And any number in between, we can select to either round it up to 1 or down to 0. And rounding something down, that means down it hits the floor, so that is called floor. And rounding something up would make it hit the ceiling. I really shouldn't call it rounding, because rounding is more of a, you go either up or down, but floor, you always go down to the floor, and it's called seal, and not ceiling, but just seal. And we have those functions as well in math. If we go back here, you can see we have floor, returns x rounded downwards to the nearest integer. Okay, they also call it round. And seal returns x rounded upwards to the nearest integer. And we want to round it down so it doesn't become 7, but it becomes 1 less. This is hard, right? So we still want to multiply by 6. Then we want to add 1. And then we want to round it down. So we say our number is equal to math floor of what the number was. And this should give us a number 4. 1, 1, 5, 1, 1, 4, 5, 1, 4, 5, 3. Will I ever get a 6? That was a 6. So another 6. This seems to do the trick. So I just want to make these 3 lines into 1. And that's fairly simple, because every time you use a variable, you could have just as easily put whatever that variable was. So instead of using number here, please ignore whatever is on the left side. I'll just fade that out a bit. So now, and now we can see the number here is the same as what is up here. So this part is the same as this part. These two would be the same. So I can just copy that part into there, not with the ending semicolon. So now we have number is a random number multiplied by 6 and then added 1. And once again we can do the same. Say, okay, this is our number. This is where we're going to use it. We can just put everything inside of that. So our number is now our math floor, math random. So we can just erase everything else. This gives us a random number between 1 and 6. Or from 1 to and including 6. I'm curious as to if this will work. Say if I run it 100,000 times, what will happen? And to spare myself of clicking this 100,000 times and keep track, I'll just let JavaScript do the work. This is going to require a lot of code you haven't learned to write yet, so let's just ignore the code and look at the results. Once again, this is just for fun. You don't need to understand what is going on here. The main thing is that we take our line and run it 100,000 times in the aptly named function, and this gives us the result that from our 100,000 times struck with the dice, we got 0 zeros, that's good, and we got 0 sevens, that's also good, and then we have around 16,500 of 1, 2, 3, 4, 5, and 6. So almost the same probability of each one. And right now it's a bit higher probability of getting a 2 and a bit lower probability of getting a 1. Let's just try it once more to see if we get different results, and we do. Now the lowest possibility is 4 and the highest is 6. So this seems to be very well designed dice. There's an even probability of all 6 sides and no 0 or 7s. And this brings us back to the whole scaling issue. First, you want to multiply the number with what your maximum number is going to be. Is this going to be up the way to number 6? And then you're going to shift it, translate it, move it to whatever it's going to be. If it's not going to start from 0, you're going to plus whatever it's going to start from. And this works fine for as long as both numbers are positive. If you want something between -5 and +5, you would have to multiply it by the difference between these two. Let's just go all the way into that. Let's just see, just for fun. Math is fun. So once again, I'm going to start with my timeline. I'm just going to clear all these lines and notes that we made so we can start from a relatively clean slate here. And then we have our random number going from 0 to 1. And now we want it to be going from, say, -5 to, I don't know, maybe +5. And then somewhere in the middle we would have 0, and then all the other numbers in between. So if we multiply 1 with 5, that would give us all the numbers. Say, that will give us here, if we say multiply by 5 and add 1, that wouldn't give us from 0, that would give us from there to there. We don't want that. We want them to, so we don't want to plus 1. Rather, we would want it to, because we want it to go all the way down in this direction. +1 would move it there, but we are going to move it there. So no plus. Instead, we are going to say, I just need the red pen here. X that out, and then say, okay, so we still multiply by 5, and then we subtract 5. So this would give us, and let's try to, so multiplying by 5 would give us this portion here, but then we would shift it downwards, so it would be there. That's not enough, because we want it to go all the way through from -5 to +5, and the total distance here is of course 10, because it's the maximum minus the minimum. And if we take our trusty old calculator, I still have calculators from last, then it would be 5 minus 5, and that is 10. As you might remember from back in the old days, minus gives plus. So we shouldn't multiply by 5, but by 10. Strike that out, and strike that out. So if we multiply by 10, then we would get all the numbers from 0 to 10. Let's go, that goes outside the screen. And then we say minus the 5. So we take, oops, I shifted it a bit. So we say these 10, we just shift minus 5. And now we have a number between minus 5 and plus 5. So this tells us that what we need to multiply by is our maximum number minus our minimum number. And then we need to plus the minimum. Let's try if we can use that in our dice here. So we just need the other. Let max be 6 and let min be, no, not 6, 1. And let's see, we get a 5. And a 4, and a 2, and a 4, and a 1, and a 4, and a 5, and I just want to make sure that this works just exactly as before. So I'm going to copy these lines of code into my run 10,000 times test and run it. And oh, there's a problem. I don't get any 6s, but I get a lot more 4s and 5s. Oh, not a lot more. I only get from 1 to 5. And yeah, because now we say max minus min. So that's 6 minus 1. And that's only 5. So we only multiply by 5 this time. This line here would be the same as if we wrote multiplied by 5 plus 1. That wasn't what we had before. We wanted to multiply by 6. So the problem with this line is that the minimum is included, but the maximum isn't. Just as in math random, that doesn't include the 1. So we need to, okay, to be sure that this works, we need to, okay, we want to include it, so we plus 1. Simply plus 1 here. That would work. Now we include the end as well. That's all it takes. Let's try it. Because we have 5, we can run 100,000 times, and we have 16. The reason I do this with running 100,000 times is that I do not trust my own math abilities. So I want to make sure. And of course, mathematically speaking, my old math teachers, they would beat me up, as if they didn't already at all the exams. They would beat me up and say, you cannot prove math by just trying it. You have to actually prove it. But we're not even going near that. I'm certainly not. But we have these two formulas. This one, if we want to find a number excluding max, and this one, if we want to find a number including max. So this is the important lesson from this. This is the math that goes behind using random numbers, where we want whole numbers from one value to another, and not just from 0 to almost but not quite 1. I hope you enjoyed this mathematical adventure.
Math.